Good morning, Algebra 2 students. Happy Wednesday. I hope you're easing back into the swing of school this week. I'm getting a little better. But today's topic is a continuation of what we did on Monday. So I'm going to call it Evaluate Logs 2. I'm going to do 3 problems. Problem number 1. Log base 125 of 5. All right, that's the problem. That's the logarithm that we need to evaluate. What we're trying to figure out basically is what power of 125, because 125 is the base. The way I remember that that's the base is it's below the word log, like a little bit. So 125 to what power equals 5, remembering that the log is the answer. I'm going to make an equation, and I'm going to have it equal to x. So that's the first step. Just write equals x, because we're trying to find out what it actually equals, what the log 125 base 125 of 5 equals. So the first step in evaluating a log of this form, when it's not obvious what power I have to raise 125 to get 5, it's going to have to be a fraction, because 5 is obviously a smaller number than 125. So I can't square it. 125 squared is going to be a huge number. So 125 to what power equals 5? What's that? That's what that is. And to re-emphasize that and to show the connection between logs and exponents, let's rewrite that as an exponent. So the first step is to write it equal to x. The second step in solving this type of log is to change it back to exponent form. 125 is the base, and what power, the exponent is the answer over there in a log equation. So I'm going to put the exponent back where it normally goes, and I'm going to say that equals 5. That's kind of what I've been saying in words for the last couple of minutes, and now I'm just writing it out. So we've changed a log equation to an exponential equation. Now the trick is to try to find a common base. Well, the only base that I can see inside of the number 5, besides say 1, is 5. It's 5 to the first power. So I'm going to write a little exponent there. 125, I'm hoping that we recognize that also as a power of 5. That's one of the skills you're going to have to sharpen a little bit in this series of lessons with exponents and logs. You're going to have to get used to recognizing powers of numbers. But I'm going to rewrite 125. If we look at the powers of 5, 5 is 5 to the first. 5 squared is 25. 5 to the third power is 125. And you'll get probably some problems that may have 625. That's 5 to the fourth. Again, you have to kind of get used to seeing those and recognizing those numbers. So I'm going to rewrite 125 as a power of 5 by writing 5 cubed. And that's still raised to the x power. I have to put parentheses around it. And that equals 5 to the first. The next step is to use the power rule. When I'm raising a power to a power, I just multiply the two exponents. So 5 cubed to the x, in other words, this power being raised to another power, you just multiply. So it's 5 to the 3x is equal to 5 to the first. This is the good part right here. Now that we've done all the heavy lifting, I have a 5 on each side of the equation, and they're both being raised to a power. So if the same base is being raised to a power, those exponents have to be equal to each other. So that means that we can get rid of the base and just change it to 3x is equal to 1. Last step is to divide by 3. So that means that x is equal to 1/3. And we can check. Does that make sense? Does 125 to the 1/3 power equal 5? Yes, it does. If you remember how to rewrite exponents as radicals, this is basically saying 1 to the 1/3 power. Remember, a fractional exponent is just a radical with the index and 125, and the exponent is the numerator, the index is the denominator. Cube root of 125 is 5. That's how you evaluate a log. Okay, you don't have to check each time. If that confused you, that part, or if you can't remember that, it's not important. The answer is 1/3. Let's erase the board and go to another problem. Problem number 2. Evaluate this log. The log base 8 of 128. The first step I'll remind us to do is to put it equal to x. The second step was to change the exponential, or excuse me, change the logarithmic equation into an exponent equation. So 8 is the base. The answer is the exponent. And the log goes on to the other side. So it's changing the log base 8 of 128 equals x into 8 to what power equals 128. That's what a log is. Then we have to try to find a common base. I'm hoping you stumble on 2 because that's the correct number. 2 to the first, 2 squared is 4, 2 to the third is 8, 2 to the fourth. You're going to have to get good at recognizing these numbers. 2 to the fifth is 32, 2 to the sixth is 64, and 2 to the seventh power is 128. So I'm going to rewrite those two numbers as powers of 2. I'm going to change 8 to 2 cubed, and that's raised to the x power. And I'm going to change 128 to 2 to the 7th power. Raising a power to a power, you multiply the exponents. 2 to the 3x is equal to 2 to the 7th. Now that the bases are the same, the exponents must be equal, as we said in problem number 1. So I can change the equation to just 3x is equal to 7. Divide by 3, x equals 7/3. There you have it. Let's do another one. Problem number 3. Log. This one is going to freak some of you out maybe, but that's okay. I'll guide you through it. The base in this case is 64. So the log base 64 of 1 over 128 is equal to x. I already did the first step, making it equal to x. Now I have a fraction involved, which don't worry about that. We'll deal with it in a minute. The first step after putting equal to x is to change the log equation to an exponential equation. The base is 64. 64 is raised to the x power. Base, exponent, answer, 128. Excuse me, 1 over 128. So 64 to the x power is equal to 1 over 128. Well, as we saw from the previous problem, 64 and 128 are both powers of 2. 64 was 2 to the 6th power, and 128 was 2 to the 7th power. So let's rewrite those two numbers as powers of 2. So 64, 2 to the 6th raised to the x power. is equal to 1 over 2 to the 7th. No worries about the fraction. If you'll remember when we reviewed exponent rules back before, or that first week after all this happened, if you remember, when I had a negative exponent, like 2 to the negative 3 power, I changed it to a positive exponent by putting it in the denominator. That's 1 over 2 to the 3rd. So negative exponents were just basically another way of writing fractions. So that means that 2 to the negative 7 can be written as 1 over 2 to the 7th. Well, look at that. That's what we have here. We have 1 over 2 to the 7th. So that must mean it was originally 2 to the negative 7 before they got rid of the negative. On the left-hand side, I just multiply the two powers. So it's 2 to the 6x. My next step is to get rid of the bases because they're the same. And I just have 6x is equal to negative 7. That was a negative 7, by the way. Divide both sides by 6, and I get x is equal to negative 7/6. There you have it. Lesson number 2 on logs. I hope the rest of your week goes well. That's going to be it for this week. Per our new instructions, I don't know if you've got an email from the school, but we're having a big meeting tomorrow to try to discuss how to better streamline how this goes. Anyway, I'll talk to you soon. I'll give you updates. If anyone needs help, I think Friday is the day they have set up for us to give help by having a Zoom meeting or something like that. So they're also going to, I think, come up with a time slot for individual help in each class period. But if you haven't gotten that email, I'll summarize all that information and send it to you in an email on our Algebra 2 group. Anyway, hope you're having a good week. Happy Wednesday, and I'll talk to you soon. Bye.